Welcome to our discussion about how manufacturing is being transformed by data. Earlier this year at HPE's Discover 2021, our CEO Antonio Neri coined the phrase about the fourth V of big data. We've all heard about the volume, velocity, and variety of big data. Now in the age of insights, let's get to the fourth V, which is the value of that data. I'm joined here by my APAC regional colleagues that are working with numerous customers on their data transformation projects to drive AI and ML into their operations. Stapan is the Manufacturing and Distribution Industry Vertical Chief Technology Officer, and Ridhav is leading HPE's Software Solutions Engineering team here in APAC. I'm Tariq Shalwani, and I'll be the facilitator for this conversation. So Stapan, across the various manufacturing customers you've helped with their transformation in the region, what are some of the trends and challenges that you're seeing?
The current pandemic has created new challenges for every industry, and manufacturing industry is no exception. Some of the challenges that we are seeing in the industry are basically due to four major trends. So the first one is around increased customer expectations. Second one around changing business and trade scenarios. Third one around technology advancements. And fourth one around emerging new business models. A lot of emphasis right now is on data, because now we have advanced frameworks that can handle all forms and types of data, especially the semi-structured and unstructured forms of data that are generated by the machines, and which going forward will constitute 90% of all the data generated as per a recent popular survey. This raw data, if turned into valuable information through real-time and historical analysis, through AI and machine learning and deep learning models, will help drive automation, create more efficient and productive factories, and provide better personalized services. And it will also help in create and generate new revenue streams for the organization. So data and information has become of paramount importance and will play a significant role in the success of manufacturing and distribution industry going forward.
That's great, Stapan, and that really resonates with what some of the conversations we're having with our customers, system integrators, and the ISVs in this region. Really, the supply chain, distribution, and manufacturing space is completely transformed due to this pandemic. And I see also that managing data is a really important part of what you mentioned. So beyond the application modernization, digital transformation is really about deriving value from data. Stapan, can you discuss what that data journey for these customers has been, and where are the common pitfalls that you've seen so far?
Sure, Tariq. So every customer's journey is unique. I'm going to talk to you about generic maturity model. So as with any data initiative, the first step is about getting or ingesting the data. I call this stage as beginner or starter stage, in which the customer identifies the data sources and starts ingesting the data in its raw format. Second stage is where the customer identifies a few use cases and tries some proof of concepts to evaluate whether these advanced analytics, AI, and ML technologies really make sense to their organization. Examples of such use cases include condition monitoring, identifying false signatures, AI-based quality assurance, etc. This stage is the point solution stage. Most of the customers that have interacted so far have been in these two stages predominantly. After that, the customers look at creating a comprehensive technology stack to productionize the analytics, AI, and ML workloads. They look to expand their use cases and standardize their environments. Predictive prescriptive maintenance, root cause analysis of defects and anomalies, predictions and recommendations are a few use cases that I can think of in this stage. An edge-to-core data lake architecture, containerized platforms, frameworks and processes for analytics and AI model development and deployment are part of standardization exercise. Finally, the customer looks at optimizing the environment and bring automation as part of analytics and AI practice. They mostly adopt DevOps, MLOps kind of tool sets to orchestrate their environments. The customer develops more and more complex use cases of analytics and AI into this while they are in this stage. Like I said before, these stages might differ from customer to customer and case to case basis. Most of the customers, around 80 to 85% of them, have challenges in moving beyond point solutions. This is because To operationalize these environments at a production scale is a complex task that involves different tools and frameworks, processes and skill sets, adherence to compliance and security practices. On top of that, AI ecosystem with open source platforms is a constantly evolving ecosystem, and there are a lot of niche ISVs and partners in the market as well. The deployment also requires different infrastructure from a capacity, performance, and scale perspective, as well as tools to optimize that infrastructure. Over the past few years, I have been working with various customers to design and simplify these environments with HPE technology stacks and tool sets that are flexible, secure, and easy to manage in an edge to cloud deployment model.
That's great, Sapan. And I think the way you've painted the picture of that journey, it's really exciting for manufacturers to actually adopt this methodology and move along the progression. It must be quite frustrating for some of them that are just stuck in the operational and point solution stage. So maybe Ridhav, what are some of the technology pillars that you're seeing that are the foundations that customers can start to build their data stack and their entire enterprise architecture on to move further along that maturity curve?
Yeah, sure. So what we are seeing with most customers is that they're trying to sort of build this global data fabric layer in their organization to basically bridge the gap between OT and IT systems. So there was a time where customers were, when they were starting these initiatives, as you mentioned, beyond the app modernization, when customers start to modernize their data stack, one of the key things that we look at most advanced, organizations in this journey is that they start with setting up this foundation of data layer as a unified global data fabric from edge to the cloud. So what I mean by that is a technology foundation, which could in its small format can be deployed at the edge. But at the same time, when it gets deployed on your core ecosystem, it could scale to handle all of your organization's data. But at the same time, it gives you a unified access layer. So your applications or your intelligent applications you're building, irrespective of where you are deploying them, be it at the edge or the cloud, this common data fabric layer provides it a unified data access. And once that sort of foundational data platform is set up, the next thing is about setting up a scalable compute layer, which allows you to, understand and get the value out of your data, because obviously capturing data, with the 3 V's, as you mentioned from Antonio's statement, is one thing, but it's about getting the value out of the data, which is where that scalable analytics layer come into picture. And then also machine learning, because a lot of these traditional analytical workloads we used to run in our businesses to get better understanding of the business can be further enhanced by AI and ML layers. So AI and ML is no longer just technology buzzwords. So this is where organizations set up the third pillar of, having a factory approach to productionizing machine learning and deploying it in their entire organization.
That's really interesting, Ridhav. And I see that the data platform and that global data fabric that you talk about is really the starting point for all of this. In terms of how enterprises manage this expansion of data from edge to cloud, could you maybe discuss some of the functional use cases and the benefits that you've seen in the marketplace?
Yeah, absolutely. One of the key challenges in the legacy systems have been that to be able to deliver a number of data capabilities, you need to be bringing together 6 or 7 different technology stacks, from messaging systems to databases to the time series databases, to bring those things together to deliver your use cases. What that meant was that when the IT started positioning these to the OT stacks to deploy these technologies at the edge, you don't have that kind of power and compute at the edge to be able to take your entire IT systems and deploy there. So the changes we are seeing in the market is that the concept of this unified global data fabric that allows you to deploy a small footprint edge cloud, where you could stream your real-time data from your edge devices to be able to capture it and analyze at the edge itself and apply machine learning at the edge. but at the same time, learning from all of your global deployments, bringing the data back to your central data repository, and then further enhancing your machine learning models. For example, one of the customers I have worked with, they were able to increase the efficiency of their, one of their nitrogen plants by almost 40% by correlating the data coming in from one manufacturing site and comparing it with the same equipment which was working in other 7 manufacturing plants across the globe, by again applying the machine learning, understanding what were the factors which were impacting the efficiency of that environment. They were able to sort of learn from the global deployments and applying it back to the edge, which is kind of goes back to the technology deployment we were discussing earlier.
Wow, that's fascinating. Sapan, maybe you could also share about that architecture that you've been promoting recently to our customers, which kind of encapsulates everything that Ridhav has mentioned.
Yeah, sure, Tariq. So edge to cloud architecture is relevant for those organizations who have edge locations such as factories, retail stores, oil rigs, utilities. The data that is generated from the machines or any other source is ingested through a gateway and is stored in the edge cloud environment. The edge cloud environment should ideally host an edge data lake that provides services for real-time stream analysis and also provides storage capabilities for all forms of data and compute to view the information and run AI inference algorithms at the edge itself. The processed clean data is then sent securely to a central location, which can either be a public cloud or a private data center. There, the data can be used to train AI machine learning algorithms or to run advanced analytics for all the data that is generated at the edge locations. The edge cloud should be simple to deploy, manage, and operate. Data movement should also be automated and efficient. The advantages of such architectures are definitely better performance and low latency because the data is analyzed and in there itself. You need low network bandwidth between the edge locations and the core data center or to the public cloud. And in turn, you save a lot of cost there. This also creates the foundation for a self-reliant edge location, which can operate even in case of network or core data center or a public cloud outage. So that way, we could provide a platform that supports the customer's business needs and also scales as per the customer's data growth.
This is a great architecture that you've shared, Sapan. It'd be great to see how you've maybe used this architecture to help one of the customers in the region, of course, without mentioning their name.
Thanks, Tariq. So here I would love to really mention about a customer who's in the Southeast Asian market. The customer is ingesting data from various machines and has implemented some AI point solutions around AI-based quality assurance as a key step towards their Industry 4.0 journey. The customer would love to do root cause analysis, predictive analysis to improve his defect tracking mechanism and to improve the yield of the entire factory flow. So, and on top of that, they also would love to have better reporting that cuts across all the functional units and business units. The challenges that the customer was facing is around data silos. So the data is actually stored by the business units and functional units in a siloed way. So what's happening is that the data science team and the IT teams are spending a lot of time in acquiring the data and preparing the data for machine learning and advanced analytics. Because of this siloed nature of storage and no central management framework, the customer is also facing challenges in terms of limited reporting abilities. And on top of that, the customer also told me that there's a risk of data security and policy enforcement for the data that is being stored by these business units. So with these challenges in mind, we kind of created a comprehensive solution that involves two fundamental components. The first one is a data lake, and the second one is a container management layer. So the data lake helped the customer to provide a single source of truth, and the container management platform provided the customers standardizations and ease of analytics and AI modeling. Basically ease of operations in generating AI algorithms. We also provided the customer with an infrastructure that is optimized for data and AI environments. With this foundation in place, the customer is able to build predictive and root cause analysis algorithms that help them to improve his yield, and that also help him to do root cause analysis for defects. The customer also became more efficient in terms of reducing time that he's spending to fetch data that is spread across his business units. Because right now, the data is all in a centralized single source of truth. So the customer's IT teams can dig into this central single source of truth and convert this data into meaningful information. It helped the customer to improve his speed of innovation and reduce the time to value. And because the data is in a central location, it also enabled the customer to do comprehensive reporting. And the infrastructure and the platforms that we provided are quite flexible and also supported the customer in terms of its growth strategy as well. This is how we helped the customer to move from point solution to a comprehensive data and AI ML strategy.
That's a great example and a case study of how HP has been able to help this company. So I think this company is not only a Southeast Asian company, it's actually a global company that had a real AI issue here in Southeast Asia. So I'm glad to hear that you were able to succeed. So I think let's try to summarize the discussion around this data, AI, and analytics continuum. And talk about what is the common thread that our customers are sharing with us, and why they're concerned about how they will manage their data and ensure its protection, security, and compliance, while still being able to create value from it. So we start with modernizing and securing your data, traditional data environments. And this involves understanding the applications and porting your structured, semi-structured, and unstructured data to its optimal environment. Next, we tackle the unification of the various data architectures. And this is where the global data fabric is critical to bringing the value of the data lake from the edge to the cloud. Data is ingested at the edge using the big data pipelines, leveraging open source frameworks such as Hadoop, Hive, Spark, and Kafka. And this is made possible with HPE's Ezmeral Data Fabric software, which makes it easy for the data to be useful where it is, without having to move it around and utilize networks that could be offering latency or could be compromised themselves. Then we move on to generating insights from the data at any scale. Real-time edge analytics requires that global data fabric at the edge, together with the robust compute power, can be brought together with HPE's own hardware. This technology leverages GPU for artificial intelligence and inferencing at the edge. And this is where HPE's Ezmeral MLOps toolset is a critical component. The end goal is to be able to monetize your data, and various companies such as HPE itself have pivoted our business model to becoming an everything as a service company. We were able to do so because we leveraged the telemetry data of our products to gain insights about how and why our customers used our products and what they wanted to consume about it. And this is why I should conclude by saying that HPE is able to offer all of its data, AI, and analytics continuum as a service, while still being able to offer the entire value proposition, whether it's at the edge, in the data center, or in the cloud as a service, and with the security and privacy and the compliance that you need. Data is fundamentally the real intellectual property of every enterprise. The people, algorithms, and the business models will move around and will iterate. But data in all its forms belongs to the enterprise. And to generate the growth that your shareholders and investors expect, it is important to leverage the data that belongs to you while ensuring the security of that data. So I thank you for joining us today. And Sapan and Radav, stay safe, and I look forward to seeing you soon.
Great. Thanks, Tariq.
Thank you, Derek.